Programs often need to repeat work. Instead of writing the same line 10 times, we use a loop. A loop runs a block of code again and again until a condition tells it to stop. Today, we explore 3 loops: for, while, and do while. A for loop is used when you know how many times to repeat. It has 3 parts: start, condition, and step. For example, start at 1, repeat while I is less than or equal to 5, and add 1 each time. A while loop checks the condition first, then runs the block. It is used when you do not know the exact number of repeats. For example, while the tank is not full, keep pouring water. A do-while loop runs the block first, then checks the condition. This guarantees the code runs at least once. For example, ask the user for a password, then check if it is correct. Let's compare them side by side. The for loop counts. The while loop checks first. The do-while loop acts first, then checks. Each one fits a different situation, but all 3 repeat a block of code. Every loop needs a condition that eventually becomes false. If it never stops, you get an infinite loop. For example, while 1 equals 1, the program runs forever and freezes. Loops are everywhere. A for loop adds numbers from 1 to 100. A while loop reads lines from a file. A do-while loop shows a menu until the user picks quit. Each loop saves you from repeating code. To recap, a for loop counts a fixed number of repeats. A while loop checks before running. A do-while loop runs once, then checks. Pick the loop that matches your situation and let the computer do the repeating. Loops repeat code. Instead of writing the same line 10 times, you write it once and let a loop run it. Today, we cover 3 kinds: the for loop, the while loop, and the do-while loop. Each one solves a different repeating problem. The for loop runs a known number of times. It has 3 parts: start, condition, and step. Start sets I to 0. Condition checks I less than 5. Step adds 1 to I. The body runs 5 times, printing each value. Use a for loop when you know the count. Print a list of 10 users. Sum numbers from 1 to 100. Walk through every item in an array. The counter handles the rhythm, so you focus on the work inside the body. The while loop runs as long as a condition is true. It checks first, then runs the body. If the condition starts false, the body never runs. Use while when you do not know how many times you will repeat. A real example: read input until the user types quit. You do not know how many tries it takes. The while loop checks the input, runs the body, and loops back. When the user types quit, the condition fails and the loop exits. The do-while loop runs the body first, then checks the condition. The body always runs at least once. This is perfect for menus, prompts, and password tries, where you need to ask once before you can even decide whether to repeat. A real example: show a menu, ask for a choice, then check if the user wants to quit. With do-while, the menu appears first. Then the condition decides whether to show it again. Compare this to while, which would skip the menu if the flag started wrong. Quick recap: use for when you know the count. Use while when the condition is checked first. Use do-while when the body must run at least once. Always update the condition inside the loop, or you will get an infinite loop. Every program needs to make decisions. Conditionals let code choose a path. If a condition is true, one block runs. If it is false, another block runs. This is how programs react to input, data, and user choices. The simplest form is the if statement. The code checks a condition. If age is greater than or equal to 18, the program prints "you can vote." If the condition is false, nothing happens, and the program moves on. The else clause handles the other case. If the condition is true, the if block runs. Otherwise, the else block runs. Every path is covered, so the program always does something. Sometimes you need more than two choices. The else-if chain checks conditions in order. If score is above 90, grade A. Else if above 80, grade B. Else if above 70, grade C. Otherwise, grade F. When you compare one value against many options, the switch statement is cleaner. It picks a case that matches the value, runs that block, and uses break to stop. A default case catches anything that does not match. Here is a real example. The user picks a menu option. Case 1 shows the profile. Case 2 opens settings. Case 3 logs out. Default prints invalid choice. The switch routes the value to the right action. If, else, and switch solve different problems. Use if, else for ranges, comparisons, and complex logic. Use switch for clean matching against many fixed values. Both control flow, but readability decides the winner. Conditionals are the foundation of program logic. If, else handles two paths. Else if changes many checks. Switch routes one value to many cases. Master these, and your code can respond to anything. Every program faces choices. Should it show a welcome screen or a login page? Should it approve or deny a request? Conditionals let code decide. They check a question, then pick a path. Without them, code runs the same way every time, no matter the input. Start with the simplest form. If. The code checks a condition. If the condition is true, it runs a block. If age is greater than or equal to 18, then show the adult page. Otherwise, nothing happens. One question, one outcome. Add else to cover the other path. Now both answers are handled. If the password is correct, grant access. Else, show an error. Every input now has a clear response, and the user never gets stuck in silence. Sometimes there are more than two paths. Chain else if to test several conditions in order. If score is above 90, give an A. Else if above 80, a B. Else if above 70, a C. Else, a D. The first match wins. When you have many fixed options, switch is cleaner than a long chain. Switch on the day. Case Monday, run the stand-up. Case Friday, send the report. Default, do nothing special. Each case is a labeled door for one exact value. Use if and else when conditions are ranges or complex checks. Use switch when you compare one value against many exact matches. Switch reads faster and groups cases neatly. Picking the right tool keeps your code short and easy to follow. Conditionals can nest, but be careful. Deeply nested if statements get tangled fast. Flatten the logic with early returns or combined conditions. If the input is empty, return now. Clean conditionals make bugs easier to spot and fixes faster to ship. To recap, use if for one path, if else for two, else if for ordered chains, and switch for many exact values. Conditionals turn raw input into smart behavior. Master them, and your programs start making real decisions.